Okay, so we just got done constructing frequency distribution tables and histograms and polygons from raw data. So now what we're going to do here is, once we have collected the raw data and made the frequency distribution table, how is it that I could construct the frequency distribution? And also, how can I graph those corresponding histograms or polygons? I'm not going to do polygons. I'll show you so see the previous video to get the polygons. But over here, we're going to focus on this histogram and how we have to rescale. And the importance of rescaling and making sure our scalings are consistent with equal jumps. This is where things become very important, especially if you're graphing, and you don't want to make any type of misleading graph. So we don't want misleading graphs, and you'll come to see what I'm talking about when we're resizing. Okay. So come over here. We're going to be focusing on that for right now. So we're going to develop the frequencies, distributions, and drawing the corresponding histogram. So let's go and get started. So come over here. I keep the same data here so we know where the data came from and the same class intervals, so I'm not changing any of that. But we're saying that what if this had this? What if we only knew this? And we want to graph the histogram. Do we have enough information to do so? And the answer to that question is yes. We have enough information to graph the histogram. The only thing we don't know at this time, I know my lower limit, I know my lower limit, I know my upper limit. Okay. But I don't, at this time, I really don't know my class size or my class width or interval size for other classes. Okay. So how do I do this? Well, we've already said that if we wanted to do the interval size before, we said, oh, if I knew 10, how do I get 25? Well, I did it by adding 15 and repeat the process over and over again. So, okay, but what if I didn't know this? What if I didn't know that this was here? Or you could do it by hand, say, well, it's here to be 15, but sometimes that might be a little hard because you have decimals. That might be a little hard. So how could we do this without killing ourselves and throwing ourselves under the bridge? All we need to do here is we could go for the real limits. And our real limits is key. So our real limits was supposed to be 10 to 25. That's real limit. The 24 is not real limit. It's the upper limit, but it's not the real upper limit. The real upper limit is the next class's lower limit. That we're saying that, hey, I'm going to start here, so anything less than me should go to the one below. That's what the lower limit is saying. So therefore, if I want to find the class interval, or the class will refer to as interval size, or I'm saying, when I say class width, sorry, class width, I'll write right here. We will find it by getting the difference of the classes or intervals. The class or intervals real limits. Okay. I'm pretty sure that in your book, instead of saying real limits, they're going to say boundary points. They're both the same. Once again, where the boundary point, it says it's halfway between each. So once you know the pattern, just go half each time. So come over here, what we're seeing, if I just look at the real limits themselves, what I'm seeing is it's going to be 15 minus 20, I did it wrong, 25. Where did I get 15 from? 25 minus 10, which that gives us 15. That's where that's from. I was thinking about the answer right away. And that's using the real limits. What if you want to use boundary points? Well, understand boundary point is poking half of these guys downwards because we're shifting it down a half to get to the lower limits. You have to go halfway between the lower limits to get to the halfway above the upper limit. So we are good with that. And one second, so 24.5 minus the 9.5, which is going to also be 15. And that's our boundary point. So we're good with that. Okay. So let's just go ahead and push forward, and let's just go ahead and get the rest of this good stuff in here. So the first 2 ways of doing it, it really is your choice on how you want to do it, depending on how your book does it. But just keep consistent. So now, once again, how do I graph this histogram? Well, since I know the class width, now I could actually put it into the graph. I mean, like we did before. Okay. So what we do here, I'm going to do some adjustments. So I'm going to turn on. I already have these in here. Wrong one. Stats. But I don't want this regular this data anymore. Okay. So say if I don't want this data no more, I don't want to move this over, I have to readjust all these things up here, and I don't have enough just to do so. I could pretty much clear this guy. And notice I already have the lower limits here. The list of lower limits. So I could copy it over here by just highlighting R1, entering it, and say I want you to get all 2s. And it will bring it over like that. So I can do the same thing for R2. I want to take over R3 because that was the frequency that corresponds with it. So I could clear this one here, and then I could ask for it to do R3. Or enter it, and then on R3. And this copies is over. Nice. How that works. So over here, I could now clear these rest of guys off because these guys are going to be changing, so I don't want them here. They're gone. Nice. So let's go ahead and push forward from here and get to the other ones. So once again, how do I got this again? Well, I already have the windows to be set up the way it is. When I like to see the scales to see how these are, so when we do combobulated. So all I really did here was I just extended. I knew it was 85 row upper limit. I just went one more down, and I made it to 100, so I could see what's happening. I could get a better view of the histogram instead of reading 2 counts from screen to screen. And except over here, all I did was I minus 15. I'm making it into -5. So that's all I really did. I kept everything the same, so notice how I still got the class width that I found, and I made sure that that's in there too. Okay. And just go readjust from there, but that's all I did. Just so when you get the graph to look not too crammed in. I graphed it, oops, I forgot. When you see this dimension error, that means that you literally have lists, you're trying to graph lists that don't exist. So make sure, so I'll quit it and then I'll go back over here to my second plot. And notice how when on plot 2, it says I'm looking at list 2 and list 3. Wait, I don't have no list 3. So this here shouldn't be on, it should be off. So I'm gonna go to it and turn it off. And I go up to the top and look at select list 3. And notice how it's doing list 4 and 5. I don't have these guys. So I have to make sure that I turn it off. If you don't turn them off, it's going to be trying to grab something you can't grab. It's just a dimension error. So please make sure that that doesn't happen. So now we'll go back to plot 1. It's on. We have the histogram. That's good. List 1 was our lower limits. That's what you want. But the frequency is supposed to be not 1. It's supposed to be the corresponding frequencies that go to the lower limits, which should be this 2 that we have on the table. So now I could graph this. I'm going to graph it. I get back to the histogram I got before. So like once again, all we did was say this was our list 1, and this was our list 2. That's all we did. So now the question is, okay, I got the histogram, looks nice, and I could graph it over here and get these in here. So let me just go ahead and regraph that for us, see how it's being consistent. And notice how over here I did scales of 2 and then ended at 10. Keep that in mind. That's what mine did. I did scales of 2 and ended at 10. So over here I want to do it to get 10 in here and try to get scales of 2. But notice we have 1, 2, 3, 4, 5, 6, 7. Not enough. So I can't do 10. Let's go 3 more up. And I might have the luxury to do so. So I can just rescale it here to be appropriate, like I did before. So remember, the y-axis is supposed to be your frequency at this time, or any type of frequency we're going to be doing. So we have frequency, and we know these are your y values. And on the bottom, we have, once again, our x values, which is supposed to be the variables we looked at, and that's the driving time, okay, in minutes. And so we could even put the title to be driving time, and then we could obviously realize that we just write the minutes here and we know what we're talking about. But this right here is what your x is. And like we did before, you have a choice of either using your real limits or your boundary points. It really comes down to how the book is doing it. So keep listening to the book that you have, because that's going to either make you or break it. Okay. So when you do histogram, it's going to be real limit. So all we have to do is, if you want to do your trace, all we have to do is just go halfway between each one. Over here is supposed to be 0 because there's nothing there. Does that make sense? But go to the first interval that we have. It says that the real limit is 10, and the real limit is 10, and the real limit is 25. So I can just go halfway down from each one, because halfway between is 0.5. So that's for my boundary points. When I get my blue or green for this one, my boundary points BP is supposed to be, right here is supposed to be 24.5. Over here is going to be 9.5. So we could pretty much see the pattern from here, what's happening, or we could just go ahead and shift to the side and do the trace and see what everything else is doing. Okay. Over here, it says, the next one should be halfway less from 40. So we're looking at pretty much 39.5. So we're pretty much getting the same thing here, just going halfway. So 54.5. 69.5, and over here, halfway between the real limit and the upper limit is 84.5. So I got my boundaries, so I could choose boundaries here, or I could do the real limits. Okay, it depends on what the book is doing here. Okay, guys? So over here, I'm gonna do my scale, and I'll do it based off the lower limits, or the boundary points. So we're gonna have our 9.5 here, our 24.5, our 39.5, our 54.5, did you do that right? Yeah, 54.5, our 69.5, and our 84.5. So those are evenly spaced apart, that's good. And on frequencies, like I said before, we can't get 10 from here, we get 7, but that usually will not be a friend every single time. So what I'm gonna do here is I'm gonna go by 2s for every grid line. So 2, 4, 6, 8, 10. So 10 is definitely here, and I can just push forward or just stop at the 10. And I can do the corresponding graph from here. So when doing so, we know that it's supposed to be 6. I gotta get them knees again to get a good angle. We have this happening between 7 and 6 and 8 is 7. So we go halfway up, get it there. We have a 7. Then we have, it's supposed to be 4, which is right here on this line. 4, followed by 2, and lastly 1. Oops, a little high. Halfway between 1. So now we have our graphs. We have regraphed the frequency distribution table. So now, what if I wanted to find the relative frequency distribution table in a proportion or in percentage? Usually, most books do it this way for percent and proportion, but usually it's just RF, and we have to label it as proportion percent. So over here, we definitely know that this is a proportion, and I'll do that in red. This is a proportion. And over here is almost a percent. Okay? So we could definitely go with that. I usually write prop for short and for second for short for percentage, but we're gonna get to that later. Okay, so now, how do I get the relative frequencies? We'll get that situated right now. And almost done. We'll get that situated right now. And when it comes down to relative frequencies, what we're seeing here is, if I'm doing relative frequencies for proportion, our proportion should equal our frequency over n, which is the number of observations we have. So when I'm saying the number of observations we have, how do I find the number of observations we have? We pretty much look at the sum of all the frequencies for the frequency distribution table. So when we sum them all up, we're looking at pretty much 6 plus 7 plus 4 plus 2 plus 1, and that should equal 20. Okay? So that's what's happening for the proportions. So if we want to get the first class, the one that has 10 to 24, we know its corresponding frequency that we had was supposed to be 6. So if I want to do relative frequency and proportion, for proportion, what we're seeing here is going to be 6 over 20. And we want to write this in decimal form. But we usually round to 3 to 4 decimals for accuracy. So your book will give you a certain rounding, but I usually do 3 to 4 decimal round off. Okay. To keep accurate as much as possible. So that means that every frequency up here, we're going to correspondingly divide by 20. So we have 6 over 20, 7 over 20, 4 over 20, 2 over 20, 1 over 20. So we could have fun, spend our time doing each one by hand, which will take time, or we could find a more efficient way of doing so. So I'll go over show you how we could get answers on a calculator in that regard. Okay, so I'm going to go ahead and set and put this. And I want to get that 6 over 20. So over here, if you just do 6 divided by 20, we get the decimal format. But if you do the fraction, which once again, how do you fraction? Do alpha, y equals, select the fraction one. And I put 6 divided by 20 here. Notice how you say as a fraction. So this is where I have to figure, okay, how do I convert? How can I convert back and forth between these guys if I need to? Well, the conversion that we do, if we want to go from fraction to decimal, okay, is we have to find this function out. And this function out happens to be in the same region we get the fractions. So if I do alpha y equals, I see it right there. This is a fraction to decimal converter. So when I choose that one, notice how I want the answer converted, yes, it converts to decimal. And I could always go back and forth. Do I just constantly hitting back and forth? So okay. Get them to stop it. I'm recording for my students. That's not good. Now I get another 10 to 20. I don't know if that's bad. Oh yeah, I'm not using computer, I'm using the Mac. Yeah, go ahead. Okay, sorry about that. But so we have that, so that's how we convert. So therefore it is we work wonders for us in the future. But hey, that's doing what I want, and that also takes time. How can I get all of them done at the same time? Well, if you have your frequency list, you can get them all done at the same time, which is pretty nice. All I have to do is call upon the list. So over here, in this region, I could actually call upon the list by doing second list 2, and we see, hey, that's all the frequencies in the list. So whenever you have any type of list like this, it's going to say, you want me to do everything that's on that list to it, whatever operation you want me to do. It does for each and every one of them at the exact same time. So now what I'll do is, instead of doing an individual one, I'm going to do list of the frequencies, which will be L2, and we'll see it happen. So now if I do the same thing, and I do the fraction setup real quick, and I have a fraction form just like this, and now I'll do L2 instead of just 26, and I divide that by 20. we end up getting all of them to be in fraction form. And I convert the same way if I want to, or I would say, what if I just did L2 and just simply divided it by 20? Okay, but I would get all of them. So interesting thing here is doing this right here is pretty nice because I could, and in this format, I could convert it to a list. So let's say, oh, I did it here. Oops, I was supposed to do it in the list. How can I put it to the list? Well, all you need to do is go and hit this store button that's right here, right next to the one. Hit that store. You're going to say, well, want to store an answer where? Well, I want to store it to the list. But the list I want to store it to is 3. List 3. So I'm going to hit list second 3, and it says 3. So that just copies it. I'd rather say done, but it says there, I have converted to this 3. And when you go to your list, and you look at your edit, it's there. It's now in this 3, which is nice. So we could actually work on it on the side, so you can also do it here too, using the same idea. There's one thing that I forgot to show you guys outside over there, so I'm gonna do a second real quick, and that is, can we do sum without actually doing this work here? Yeah, you could type it into your calculator, get the 20, but there's also another way to do it just by looking at this, if it's already, the figure is already there. And it's still, once again, a list operation. That's what we're gonna be doing. So if I want to get the sum, I could do second list here, and I'm going to do an operation, but it's going to be under math, because the sum is right here, number 5, option number 5. That means the sum of all the frequencies in the list. So I'm going to choose number 5, and I'm entering it. And I'm going to look at list number 2, because that's where the frequencies are at. And now, when I put it in and enter, I get the sum. So I could have easily done that and got the sum as well. Hopefully that is helpful in that regards. But let me just go ahead and write down the corresponding proportions for each one of these in decimal form. Over here was supposed to be 0.3. Over here was supposed to be 0.35, followed by 0.4, 0.45, oh, I'm doing it all wrong, 0.2, 0.1, and 0.05. So we have that right there. So once again, that's how we can get to proportions using calculator technology and having our frequency distribution table in our list. It's pretty nice. So the next thing we're going to talk about here is, okay, if that's how you find proportion, how do you find percentage? How does that really work? Okay. So what we definitely do here is, I'm going to go ahead and, first of all, let me just show you something real quick, and that is, what if I wanted to combine these two together? Instead of doing 20, what if it says this instead? So I'm going to go ahead and go to the top and replace that 20 with the list, and we see how it works. I'm going to go over here and highlight this guy, and what it does, it'll duplicate it down below. So instead of putting 20, I'm going to delete this guy here. So I could just delete the 20. And instead of putting 20, I want to do that sum we did earlier. So I'm going to put pretty much second list, math operations, go to the sum, start the math, and I'm going to do it for list 2. So list 2 and list 2, it should be equivalent. And notice how we get the same answer. So there's many ways you could use the technology to get your answer. So that's out the way. So percentages. We want to talk about percentages. How do we give percentages? Well, percentages is pretty much multiply the proportion by 100, but usually we won't have proportions. Usually we have just the frequencies. So how can we do it? So I'm going to hit about the frequency, percentage format. So over here, I'll just write the percentage symbol. And naturally, relative frequency comes from getting the frequencies and divided by n, where n is probably the sum of all frequencies. And all we're going to do is multiply this by 100%. Okay, where once again, n is the sum of all frequencies. But hey, we have just recently found this already. So it kind of makes purpose for us to type this back in if we already have proportions. So what we really are doing here is getting the proportions that we found, and we're going to times that by 100%. because these guys are one and the same, and we just showed. So I'm gonna show you guys something interesting. So let's say, hey, you don't want to do all this work. Is there a quick way to just constantly getting each one multiplied by 100? Yes, I want to do it by hand. There is something called a converter that most students who are in stats learn. And that is pretty much, we could go from proportion to percent, like we did earlier. So let's just say I want to do verse 1, which was supposed to be 3, 0.3. And let's say that I want to convert the proportion to percent. We naturally know that what we're supposed to be doing is times it by 100%. And what does this really do to the decimal? When we actually see it, it's going to move the decimal over 2 spaces to the right. So now the decimal is now here. And we have an empty space right here after the 3 and after the decimal. So any empty space will become a 0. So we're definitely seeing here, when I convert it, the proportion 0.3 is going to become 30%. And if I have a percentage, I can get proportion from there. So let's say I want to go the other way, and I want to go from, this supposed to be percentage, not 100%. I want to go percentage, and I want to turn that into a proportion. So I want to start with the 30%. So if we want to go for percent, we multiply 100. So if we want to go from percent to proportion, we're going to have to do the opposite operation, which means divide by 100%. These guys here are naturally cancel. But what's really happening in the process, what we're seeing here is that if we want to get to the shortcut, we're going to get the decimal, and we're going to move the decimal over 2 spaces to the left this time. And we're going to put the important decimal word not. So anything that's blank, we can put zeros there. So this one here actually converts and becomes 0.3, which is what we had prior. So that's what you can do by hand. Okay. And then you could choose to type in your calculator manually. It's really your choice. I'm not going to force any method upon you. But over here, I'm just going to go to the list portion, where we're at over here, edit. And over here, you can just get each of these decimals. I move to the right and just write it again, 30 on. So you put 30 here, 35 here, just by moving it over 2 to the left, 20, move 2 to the right. You can do that. Or you could do the operation. So I'm going to clear this off. And what I'm going to do here is I'm going to say, okay, I want to get the proportions in list 3. And I'm going to simply multiply it by 100. And what it does, each proportion in list 3 gets multiplied by 100, and it makes this new list. So we're not really rewriting anything, it's just being done by the calculator. And we get the same result. So it's really your choice and the method you want to do. I'm not going to enforce any method on you. It's your choice. Okay? So let me go ahead and write down the percentages up here so we have that already set and good. Good to go. So we can have 30%, 35%, 20%, 10%, and 5%. So what I'm going to do here, I'm just going to quickly do one of the route frequencies because I'm pretty running short in time. I have to give space for another instructor. But what I'm going to do here is I'm going to show you, okay, how frequencies could be any frequency. When we're graphing, it could be better frequencies, it could be the two types of relative frequencies, or it could be cumulative frequency when we get to cumulative frequencies. That's why they have frequency in general, because there's different ways of writing frequencies. So what we're going to be seeing here is I'm going to be adjusting the y-axis to be the one that is going to correspond to the proportions, or that one's going to correspond to the percentage. We're always going to be adjusting. And I'll put them in quickly, but over here, when I got here, I'm going to do proportions, because that's the more challenging one than percentage. So let's go ahead and hit that, and on the right, it'll be just converting the proportions into percent. But let me just get this in here real quick, and we'll enjoy the rest of it. So over here, instead of writing frequency, I'm going to write relative frequency. So in short, I'm going to put REL for relative, and I'm going to write FE Q for frequency, and our node over here is the proportion one. But then you use no proportion if you put decimals here between 0 and 1. It's pretty obvious for most people that it is proportional. And if it's whole numbers, like we'll see the other one, we're going to say, hey, if it's between 1 and 100, then we know it's percentages. But most of the time, if you're new at stats, you won't know that. Okay, so, but first I think get rid of this. And this is where we're going to come to our little dilemma. I'm trying to write this by hand, and also in a calculator too, because we have to rescale. Crap. So how are we going to do this? Like we did for the 7, we said, oh, the maximum was 7. Okay, our max over here happens to be 35.35. So how am I going to get that into this graph? Well, we should also keep in mind there's a pattern here. And notice how we have 0.05 and 1s and another 0.05 spacing. So we have two choices we can do here. We can either have our scale be based off the 0.1, or we can have our scale be based off 0.05. Okay? One is going to be a little easier to graph than the other. Remember, 0.05 is halfway between 1, so we can always go halfway between. But then you might have the different values that are not solid like this, and you have to do some type of guesstimation. So just watch out for those. So right here, what we do here, I'm just going to go ahead and look at the 35 and say, okay, I'm going to go ahead and try and get this to be 0.4, and I'm going to use pretty much the 0.5 scale. And let's see if we have enough space for that. That's the question. Can I use the 0.5 scale to get to 4? If not, I'm going to go with the 0.1 scale and work with it from there. So come over here, 0 on the bottom, I have my 0.5. 0.05, sorry, 0.05. Then I have my 0.1, my 0.15, my 0.2, my 0.25, my 0.3, and my 0.35. Okay. So looking for us, 3.5 is here. So I'm gonna just keep with it. If you wanted to, you could go into 4. My goal is to 4, but I got 3.5, so I'm still safe. I would just have to do it by once. That would have been the issue for that one. But I'm gonna keep to what's here, so I don't have to waste too much time. Okay. And go ahead and get to the graphing. So 3.5 to 0.35 is right here on the we got 0.3, it's right here. So I'll make sure that my rectangle does it for the first interval. And there it is. Next is supposed to be 0.35 is going to be over here on this line. So I'll pretty much have it go right here and have this thing go in. Next, we have the 0.2. Oh, that's on this line. So I'll have it consistent to the grid line it's on. And lastly over here, the 0.1, we got that one's way, 0.1, same thing, this grid line. And the 0.05, oh, it's on this grid line, so we're okay. So ours was on all the grid lines, but understand, based on how you do your scaling, it might be halfway between or within the mix. And that's all because of the available grid lines and our scaling. But notice how it's always consistent every single time. I never change the scale here. I'm always doing the same jump. So if it don't fit, I readjust. So we got that out the way. So over here we can put the corresponding values, even though it's not necessary. So 0.35 over here is going to be the 0.3 here, 0.35 right here. Over here was the 0.2, 0.1, and 0.05. Okay. And on this side here, I'm just going to rescale it. So we're going to show that, hey, we're going to get the same graph, just that it's going to be different scaling if I'm going to do percentage instead. So instead of having values between 0 and 1, which is for proportions, I can make this be values between 0 and 100 that correspond to a percentage. And I'll put it over here on this side, the corresponding ones. So over here, I'm going to do the same thing. This will be the relative frequencies. This one here is going to be my percentage setup. So what we're seeing here is, obviously we start with 0, but how do we convert a decimal into proportion to percent? We just move over 2 decimal places. So we're just looking at this one here being 5, move over 2 decimal places over here, we're looking at 10, and we just repeat the process. 15, 20, 25, 30, 35. And we know this here is all based on percentages. And therefore, inside these boxes here, if we want to note them, this will be a 30%er, this will be a 35%er, a 20%, a 10%, and a 5%. Okay? And the graphs will have the same shape, but will have a different scale. That's the most important thing. So when you're graphing it on the calculator, in order for us to see this on the calculator, we have to be adjust the scale. And the maximums and minimums are there. We have to adjust. If we don't adjust, you won't see the full graph. And that's going to be the key issue. If I'm not answering the issue, no, that I'm not responding. But anyways, therefore, let's just go ahead and quickly, I'm show one of them here with the time that I have. And so we see how do we scale it on the graph and calculator. We did it by hand, so how can we do it in calculator? How can we scale it to see, hey, I can see the graph, I can see how it's being fit. So I have everything here that's needed. So I'm just going to pretty much give the information to them appropriately. So I'm going to second y equals. I'm going to turn this graph on. And I let this one be the proportion. I still want to do histograms to keep that consistent. Remember, my lower limits were this 1, so I have to keep this consistent. So this has to be this 1. And we already showed that the frequency, about the frequency in percent, we wrote this guy here in list 2. So, list 3, so we're good. And the percentage, we wrote this in list 4. So all we're seeing is that keeping that consistent. That's all we're doing. Start with that. So I'm just keeping it consistent. So that one's there. I'm going to plot 3 on top, highlight it, and select it. Turn it on. And instead of being 4, and well, 4, instead of being a polygon, it's supposed to be a histogram. So have that highlighted. And once again, we're going to base off the list being coming from the lower limit. Coming from the lower limit, so it's going to be list 1, and over here it's going to be list 4. That's where our percentages are at. Okay. So now, when I graph it, notice how everything is still based off the frequency distribution. Notice how the proportion is way small right here, and the percentage is much larger. Because look, this was 7 as a frequency. Now it's 35. So the scale is definitely changing. So how can I rescale it so it's going to work? Well, we already figured out a scale from here. The same scale we thought about right here, we're going to put in the calculator the same way. So over here we said, oh, I was trying to go for the 4, so I want to get the proportion one. So therefore I'm going to go to Windows, and I'm going to keep the X's the same. I'm not going to touch those guys. I'm going to go over here to the Y scale. So over here, the Y min says I'm making it smaller. I'm going to make that guy smaller. I want to have it evenly scaled up. So come over here, I'll just do it from here. So over here, it's supposed to be 4. My aim was 4. And the scale that I was using was 0.05. So I'm going to have it here 0.05. I'm going to keep the same scale. And therefore, if that's 0.05, I'm going to go with this 0.05 or one whole thing down from the y-axis. Just make sure we can see the y-axis. So over here, I could put pretty much negative 0.5. I just go 0.5 down. And now when I graph, notice how it zooms in. So that happened. And we'll go back over here. Oh, I know why. I said 4, so it's 0.4. I'm going to go back to trace, a window. It's going to be 0.4, not 4. That's my fault. 0.4. Because obviously proportion is not greater than 1. It's between 1 and 0 and 1. So it shouldn't be more than 1 in the first place. So I'm going to go back here, put 0.4 where it belongs. And now when I graph, we see what we have here. Okay. We see pretty much the exact same shape as what we have here. So we could print that out. Over here, I could change this guy here. Then I got to put 0.5 and it's supposed to be 0.05. But once again, you can always rescale what's over here. You can always rescale. Here's supposed to be 0.05. You keep consistent. Okay. Now, that looks nicer. And this looks literally what we have over here. Okay. So that's how we could rescale to get the proportions from the frequencies. Or we're just rescaling the Y values. And literally, if you wanted to see what the percentage one looks like, to have all those guys in here, all we have to do is rescale it appropriately. Notice over here, our scale was pretty much, the maximum was 35, but we're going to do 40 because that was my goal, was to get 40, or to get the 4, was on the other side. But notice that the scale here is now 5. So 40 max, 5 scale. So now when I rescale it, I go back to Windows, and I can rescale it. Once again, over the max. Instead of being 0.4 now, I'm going to move over 2 decimal places, making it 40. So let me just go ahead and clear that. I put 40. Over here, we're going to move over 2 decimal places. It becomes 5. So I can clear that and put 5. And for the min, if I move over 2 decimal places, it becomes 5. So I can clear that and put 5 as well. Now, when I graph it, I can see the whole distribution for the percentage throughout the frequency. And there it is. Notice how it's hard for us to see it's negative 5, so it'll be negative 5. Let me put that negative 5. I forgot to put the negative in there. So watch out for that. Negative 5, because it's a negative. I'll correct it. Now, there we go. Now you can see it. We definitely see there's the percentage one. This smaller one here was the frequency one, and this tiny, tiny one here, now there's like a line, was the proportion one. But I could graph all of them on a histogram. I could learn to save this and drop it into a box, or to Excel, something like that, or even Word document, and make some adjustments. Very nice. But anyways, that's the end of this. And that's pretty much how we could obtain all the frequencies, literally by hand, which does take a long time, but no other process because the only way for us to actually do technology